radioactive carbon dating. So carbon-14 is used to date objects in method called the radiocarbon dating. Carbon-14 has a half-life of 5,730 years and a decay constant of 0.00012. In 2016, charcoal flakes from an excavation site of an ancient human settlement in Canada were sent for radiocarbon dating. If the charcoal flakes were found to contain about 18.6% as much carbon-14 as they would have to originally contained, how old are the charcoal flakes to the nearest year? Okay, so let's go ahead and look at this one. So how do we go about solving this? So we know that we have this equation, a e raised to our k, which is negative because we're decaying, so it's going down, of 0.0003012 times t, right? So this is our equation that we're going to use, but we don't know the initial amount. We just know if the charcoal flakes were found to contain about 18%. So if 18% of left, well, 18% of what? Well, we don't have an A, right? Well, we just know this answer has 18% of this, right? So if I take whatever this is, I can really make it anything. So if I want to make it 100, then this would be left would be 18%, 0.6. Wouldn't that just be 18.6? Isn't 18.6 18.6% of 100? Okay, so I know that negative 0.000128. So I could really put in any number for A, and just my answer would be at 18.6, right? And so now I'm going to solve this. And so now we just divide by 100, and we can leave it as that. That's fine. Or just move the decimal over twice, 0.816, right? Which is just us moving this decimal over twice. So that kind of makes sense. 0.00012t. And then how do I get that exponent down? By taking the ln of both sides. So the ln of this, the ln of this exponent just moves down, right? Ln of e is just equal to 1. So we get negative 0.00012t equals ln of 0.186 divided by negative 0.0012, oh, 3 zeros, 12, negative 0.00012, and there's our t. We get an answer of 14,000 years, 14,616 years, 0.374. Okay, and so we said 7,500 years, right, is half the life, right? So 10,000, 11,400 would be half. That would be at 50, correct? And then we're at 14,000, so we're at 3,000 more, so does it make sense? Get down to 25. 25, wouldn't that just be another 5,700 years, right? So that should be at 1,600 something, right? Or 1,700. Put one there. Something like that. We should get down to 25, correct? But we're at 18% in 1,400 years. So is that reliable? And so as we look at this, actually this would be at 50%. This would be at 25. And this would be at 12.5. So now it actually does seem more reliable, right? In between, somewhere in here, right? In which it is 18.6 is somewhere in between there. So this does seem like a reliable answer.